So learning target 7.6 is solving quadratic equations using factoring. Now again, in this part of the test, you are required to use each of these methods, factoring, quadratic formula, and solving using square roots, at least twice. So there are three problems that I chose to factor. However, you could have used the quadratic formula on one of them as long as you factored two of them. I chose factoring on these though, and again, this will go into learning target 7.8, but the reason I did, all three of these have the x squared, the x, and the constant terms, and the coefficient of x squared is 1. So, to factor x squared plus 10x plus 16 equals 0, I'm looking for, to get the x squared, I would have to have an x and an x, and I'm looking for numbers that will multiply to give me positive 16, because this constant times this constant would have to multiply to give me the constant. If I need to go out to the side and do factor pairs, I can. 1 times 16 is 16, 2 times 8 is 16, 4 times 4 is 16. And I want the pair that adds to give me positive 10. So that's 2 and 8. X plus 2 and x plus 8. Now this learning target is not a learning target that is just can you factor. It's can you solve by factoring. Now, these two things multiplied together give me an answer of 0. The only way I get 0 from multiplication is if one or both of the things I'm multiplying by were 0 to begin with. So x plus 2 could equal 0 and make this a true statement, or x plus 8 could equal 0 and make this a true statement. I would subtract 2 from both sides to solve to get x equals negative 2 as one of my solutions. Subtract 8 from both sides to solve here to get x equals negative 8 as my other solution. So if I graph the parabola y equals x squared plus 10x plus 16, it would cross the x-axis at negative 2 and at negative 8. Again, another one for factoring, x squared minus 12x minus 28 equals 0. Factor pairs of negative 28. To get a negative, I have to multiply a positive times a negative. Since I want them to add to be negative 12, the negative has to be more negative, if that makes sense, than the positive is positive. So it has to be further from 0 than the positive is. So 1 and negative 28, but my sum still isn't negative 12. 2 and negative 14, there I go. 2 and negative 14 would add to give me negative 12, and 2 and negative 14 would multiply to give me negative 28. So x plus 2 times x minus 14 equals 0. The only way this works, x plus 2 could equal 0, and then when I subtract 2 from both sides, x would equal negative 2, or x minus 14 could equal 0, so I would add 14 to both sides to solve for x, and x could equal positive 14. If I graph the equation y equals x squared minus 12x minus 28, that parabola crosses the x-axis at negative 2 and at positive 14. And again, I chose this last one to factor, so x squared plus 4x minus 12 equals 0. I want the sum of my two numbers to be positive 4. I want their product, what I get when I multiply them together, to be negative 12. So I want, again, the positive to be further away from 0 than the negative, so that the sum of that is positive 4. So it would be negative 1 times positive 12, negative 2 times positive 6. That's going to be the combination that's going to give me positive 4. So x minus 2 times x plus 6 equals 0. Gives me negative 12 when I multiply the constants. Again, the inside would be a minus 2x. The outside of plus 6x, that's where that plus 4x would come from. So x minus 2 could equal 0. Adding 2 to both sides would get x equals positive 2. Or x plus 6 could equal 0. Subtracting 6 from both sides would give x equals negative 6. Make sure you not only factor these, but you solve after you factor.